Students, how are you all? We are at the beginning of chapter 6, effect of heat on matter. Well, yesterday we have discussed a few things about heat and temperature, and we had also make the similarity, or what we can say, the comparison between between a relation between types of scales we used to do. Okay, now today our topic is expansion of solid. Well, expansion of solid means when we give heat to a substance, it expands. Okay, there is a dynamic expansion of substance. So today we in our topic we'll just discuss about those dynamic expansion of matter. Volume of almost all substances increase to some extent if they are heated. It is not difficult to understand the case of heat and temperature if we explain them with the help of an atomic model. We can imagine a solid as a collection of many molecules. We can compare the molecules, force almost them with a spring. That figure is given figure 6.03 of your book, and page 168. You can see the figure. Okay, when the solid is heated, its molecule will vibrate. The higher the temperature, the more the molecules will vibrate. We have to improve the spring model to some extent to explain the real nature of solid. Well, now imagine that the molecules are vibrating due to the certain temperature. For being a special types of spring, during vibration molecules do not come very near but can move far away. Now if the solid is heated more and the molecule will vibrate much more, already you have understood that since the molecule cannot come very close due to the special types of spring but can go very far easily, so all the molecules will establish a new equilibrium to move away slightly from one another. When all molecules will move away from one another, the whole solid seems to expand slightly. Well, length, breadth, and height of the solid are expanded equally in three dimensions by the applying of heat. To analyze the expansion, three quantities named coefficient of linear expansion, superficial expansion, and volume expansion. So, expansion of solid, three types. One, linear. Two, superficial. And three, volume expansion. Well, now linear expansion. Well, the definition of linear expansion is when heat is applied, solid substance expands linearly. This this linear expansion is directly proportional this linear expansion is directly proportional to the initial length and change of temperature. Well, now this is a solid substance, this is a solid bird. Say the length is L1 of the solid bird. Heated up, heat is given, so the temperature rises from T1 to T2 so that it expands as I have told you. Now the final length become L2, right? Okay, as it is. Now the derivation tells us here we know T2 minus T1 equal to del T, the change of temperature, so that L2 minus L1 is equal to del L, the change of length also. So the statement tells us del L is proportional to L1 del T. Okay? Now see here, okay? So del L, if we vanish the proportional sign, we find a constant. This constant alpha linear coefficient. Okay, this alpha is linear expansion coefficient. Okay, so if we try to derive it, this is the equation for linear expansion, and there's also the equation like alpha we can write L2 minus L1 del T. This is another equation is used frequently when you do some math. This is our linear expansion. Now superficial expansion. Okay, so superficial expansion is same as it is when heat is applied the solid substance expands superficially. Okay, this superficial expansion is directly proportional to the initial area and change of. Okay, so as it follow through, same things come here. Del A is equal to beta A1 del T. So A2 minus A1 equal to beta A1 del T. Beta is okay. Plus beta del T. And another question, segmential beta is equal to A2 minus A1 del T. Now third, volume. When heat is applied on a solid, see, it expands volumetrically. This volume is directly proportional to the initial volume and change of temperature. So same as it is, T del V is equal to gamma V1 del T. So V2 minus V1 equal to gamma V1 del T. One plus gamma delta. Equation gamma is equal to V2 minus V1 del T. Okay. So we have discussed the three type of solid expansion. Now we will do a math regarding this topic. Okay. The length of a steel rod is 10 meter at 20 degrees Celsius. If its length becomes becomes 10.0167 meter at 120 degrees Celsius. Determine the linear expansion coefficient. Okay, now here L1 equal to 10 meter, T1 equal to 20 degrees Celsius, T2 equal to 120 degrees Celsius, L2 is equal to 10.0167 meter to what? So we know alpha is equal to L2 minus L1 del T. So alpha is equal to 10.0167 minus 10 120 minus 20. So the calculation of it, 10.0167 minus 10 divided by 10 divided by 100 minus alpha is equal to 1.67 into 10 to the power minus 5. This unit is per Kelvin. Okay. So that's how we do the math here. Okay. Well, there's a confusion here. You can see del T is equal to 120 minus 20 degrees Celsius. That 100 degrees Celsius equal to 100 Kelvin. Because change is equal. Okay. I write it here. Okay. So I guess you might understood these three types of expansion I have discussed. We'll further discuss about this expansion and how you can fit to answer these things. Okay, that's all for today. Next class we also discuss this type of coefficient and their activity, and then we follow through liquid expansion and so on. Okay, so keep studying, watch the video very sensibly. If you have any problem, any sort of thing you want to ask me, you might not understood, please leave a message in the comment section so that I might answer about this type of problem you might face. Okay, Allah Hafiz.